Thank you, Julian. All right, so over the past few days, Lou's been sharing his vision of software analytics. And he gave you a demo of it yesterday, and we're all super excited to be here and be able to talk about it in more detail. So today's agenda, I want to talk to people about how they can learn to write NURCL queries. So the query language that we invented for Rubicon is called NURCL, New Relic Query Language. And I want to go over a few examples of how you can write NURCL. I want to talk about how we're going about aggregating billions of events. So diving into the architecture of Rubicon and how we're able to do all of those complex queries very quickly. And last, I want to talk about how you can build your own analytics features on top of Rubicon. So first, a little bit of background. New Relic captures performance data from a ton of places, from your applications, from your servers, from your iOS and Android apps. And now with the release of Platform, there's 70 plugins that can collect any sort of data that you want. But performance data is a small part of your total application data. There's so many raw events that are happening inside your application that you want to be able to capture. Things like the way customers click through the apps and the features they like and they don't like, or the actual interaction with the web transactions, or even the debugging log messages that you put in as a developer to see how your code is running in production. Or what about the API calls that you put in your codes, the tickets that you add into Zendesk, or the phone calls your application makes with Twilio? And so that's what Rubicon does. Rubicon captures the raw events from your applications, from your Ruby app, from your iOS app, from your Python app. It just takes all of the raw events that are coming in from your application and stores it. And we have a nice UI that allows you to query that data, aggregate it, and visualize it. And by capturing raw events from your application, you can ask your application these really complex questions, like how many customers logged in today, or what is my average revenue per sale? What is my most used feature? Or how many people are live on my app right now? Okay, so let's go a little bit into NURCL, the New Relic Query Language. How many people here have ever written a SQL query before? Oh wow, that's the entire audience. That's really cool. So NURCL is based a lot on SQL, and the reason we made that decision, the reason we chose to base it off of SQL is because everybody in this audience has written a SQL query. So the onboarding to use Rubicon is going to be really fast because you already know how to use it. So I want to go over 4 questions that you can ask Rubicon, and for each question, I want to explore a new feature of the query language and how it allows you to get insights into your application. So those 4 questions are: how many people use the site today? How many people are using a new feature? How many people are using a new feature over time? And what kind of customers are using this feature? Okay, question number 1. How many people use the site today? So on the left-hand side, we have your the most basic NURCL query you can write. And on the right side, you have a screenshot from Rubicon, which is the visualization for that query. And that's an important thing that we're doing with Rubicon, is that we want to always try to visualize the data that you're querying. So we want the experience to be, writing a query and sort of iteratively refining that query as you are exploring. And every time you change your query, the visualization automatically updates. So you don't have to figure out the answer and then spend a bunch of time in JavaScript writing a nice D3 chart. It's going to automatically do that for you, and then you can send that visualization to your colleagues. Okay, so the basic NURCL query on the left. And what that's doing is it's selecting the unique number of users who visited the site in the last day. And let's break down this query a little bit, because all NRQL queries are going to look something similar to this. So it starts off with a select. Just like SQL, whenever you're retrieving data from Rubicon, you start with a select. And then you have a function. You have unique count, which is a function that just counts up all of the unique user attributes. And we call that an aggregation function. And you can apply that to anything, any attribute on an event. Page view is what we call an event type. So currently, New Relic is capturing 2 event types from your application. We're capturing the page view event type, which corresponds to all of your real user monitoring traffic, and we're capturing the transaction event. If you have the latest versions of our agent, all of the transactions are going into the transaction event. And so you can use the aggregation function, unique count, to get a unique list of users from any event. The last part of the query, since 1 day ago, is what we call the time window. And that's where NRQL differs a little bit from SQL. So every NRQL query has a time window. So you can say something like, since 30 minutes ago, or since 1 day ago. And a little bit more about how the time windows work. The time windows are really important because we think that when you are interacting with Rubicon, you're going to be just constantly changing your time window. Your first query might say, show me the unique users on the site in the past 30 minutes. But your next query wants to see it over the next hour, or the last week, or 2 weeks ago, or for the past month. And so we think like a really important part of that iterative query experience is adjusting the time window. So the syntax we came up with for that is very much inspired by Rails and the way they handle time. And so you can say things like, since 8 hours ago, or since 2 months ago, or since 1 week ago until 2 hours ago. You can basically express time in a very natural language way. Okay, question number 2. How many people are using a new feature? This is a question as a developer that I want to answer all the time. Like, I just want to know, like, I spent all this time working on a new feature, just how many people are using it? And this can be a hard question to ask. But with Rubicon, the data is always being collected, and it's a lot easier to answer that question. So in this query, again, I'm just getting a unique count of the users, and then I'm searching through all of my page view events for X-rays, which is a feature that we released a few months ago. And since all of my web transactions for this feature have the word X-rays in it, I can just search, and it just gives me a unique count of people who've used it. And what I think is really interesting about this is that as a developer, I don't have to put in all of this extra instrumentation into this feature. I don't have to add an event when somebody clicks into the controller. Rubicon's already collecting this information. And if I'm in a mad rush to launch this feature, I don't have to keep deploying code to get the instrumentation right. I can just go back later and create a query and explore sort of how people are actually using this feature. And so we support a lot of Boolean logic in the where clause. So you can use likes, you can use ors and ands, and you can use that to really filter down and narrow down your query. Question number 3, how many people are using this feature over time? So this is the same query as the last slide with the one addition of that syntax that's in red, the time series day. And I think this is a really cool feature because if you don't want to just get that total value, if you want to see how that value changes over time, you can just use the time series keyword. So if I want to say what the feature usage looked like over 7 days, and I want to see that by day, I can just say time series day. Or if I want to see that by hour, I can say time series hour. Or if I want Rubicon just to take its best guess, I can say time series auto. And based on that time window, it'll automatically bucket it in the way that it thinks makes the most sense. What kind of customers are using this feature? Okay, so again, a very similar queries to what we looked at before, with the addition of a new feature called faceting. So if I don't want to just see how many people who have been using this feature in the last 7 days, but if I want to see which account levels have used this feature, I can use this facet, which is a way to group the result. And the interesting thing about APM product is that's a custom attribute that New Relic is recording on our own app. So Rubicon gives you the ability to add custom attributes to the page view events that are already being collected if there's certain custom data in your app that you want to be able to query on. And so one of the things that was really important for us was to be able to query on the product level. So whether somebody was a pro customer or a light customer or a volume annual customer, which means a yearly annual contract. And so I'm able to do that. And I can see that this feature is a feature that's used mostly by some of our biggest customers. So what is NRCL good at? NRCL is designed to make it really easy to aggregate data over time. So we support plenty of aggregation functions, so things like percentiles, histograms, averages, durations, sums, mins, maxes, funnels, all of these different aggregations. And it's something that we're always working on, and we're always adding more to that. We support time windows, so we make it very easy to just query on a specific time portion of your data. We make it really easy to do time series, so any sort of aggregate query, if you want to just graph it over time, you can just add that time series keyword. And we make it easy to facet your data by different attributes as well. Okay. So how does this work? How are we actually able to aggregate 1 billion events? All those queries that I showed, they're all going through massive amounts of data, and they're returning the results really fast. They're all well under a second, usually in the 100 to 200 millisecond range. So how are we able to do those queries so fast? Okay, so there's 4 things that we've learned when working on this project around handling large amounts of data. And that first thing is, this is pretty obvious, but you need to build a wide cluster. You need to have a lot of nodes with lots of memory in them that are able to compute and aggregate a small section of the data. So we're sharding your data across a wide cluster, and when we send a query to it, we send the query to all of the workers in that cluster, and each worker is just responsible for aggregating a very, very small portion of it. And it's all run in parallel. So if you sum up the time that it actually takes to do those queries sequentially, you might see these queries taking a minute. But since they're all run in parallel and they're all only taking a few milliseconds on each worker, we're able to return that result incredibly fast. Another thing we learned is that memory is cheap, so let's use that as much as possible. In 2010, a gigabyte of memory cost $30. In 2013, that price was $4. And so we see that the trend of memory prices going down over time. So we really designed a database that can really leverages having all of your events in memory as possible. And so we spent a lot of time working on a binary, highly compressed format to be able to fit as many of the events as possible into memory. And so when you're querying Rubicon, the events are all being held on these individual workers, and they're all being held in memory. We also learned to build for failure. So when you're working with a large cluster, your server, the nodes are just going to sometimes go down. And so you have to build it into your software architecture to be able to handle that. And there's a few ways that we handle failure on our nodes. The first way is data is duplicated across the entire cluster. So an event is written to multiple nodes in the worker. And if one of the nodes that has the events that you're looking to query goes down, the cluster can automatically just fall back on the secondary place where the data exists. Another way that we're designing for failure is that if for some reason all of the nodes in your cluster, or all of the nodes that have the data that you're looking for go down, the cluster recognizes that, and it tells the other nodes to bring that event data out of a backup storage and start being responsible for it. So even if we lose all of the events on all of the nodes, in just a few seconds, we're able to bring up the backups and be able to query it automatically. Another thing we've learned is to send the cluster real traffic. So like Lou talked to in his keynote, this has actually been live on since June. And a thing that we learned that was really effective is to actually have our live customers send Rubicon queries for those dashboards in the background as like a hidden AJAX call. And that allowed us to really test to make sure that we were able to handle load. And so like, in June, maybe we were having like 2% of our customers send Rubicon queries, but now we're having everybody. And that's a really good way to just make sure things are stable, is to actually force your real traffic to load those queries in the background. Okay, so let's talk a little bit about the architecture. You probably can't read this slide too much, and I don't want to go into too much detail. This is going to be super high level, but we can talk about it more after this if you have questions. So, a lot of people have been asking me since yesterday, like, is this built on Hadoop? Is this using Amazon Redshift? Like, what's the database that you guys are using to be able to have such great performance? And the answer is we're not actually using any of that stuff. All of these systems, they're all just really basic Java services. And so this has all really been built from the ground up. So let me give you a tour of how a query goes through the system. So a query comes in, it goes to our load balancer, and the load balancer assigns it to a random router service. And the router service is responsible for coordinating the query across all of the different workers that have data for it. And what the router service does is it asks the metadata service, tell me which workers have the events that I need to answer this query. So the metadata service sends that information to the router, and the router scatters the bits of the query out to the different workers that have the data. And it's a lot more workers than just 3. But the workers then in parallel aggregate that, and they send it back to the router, and the router knits together all of those results as one result and sends you back the answer. And we can kind of talk a little bit about how this architecture handles failure. So if worker C in this example was shut offline, what happens is the metadata node is responsible for understanding the health of the cluster, and it's constantly pinging the different nodes and asking those nodes, like, how are you doing? Can you handle some queries? And if it pings worker C and worker C doesn't respond, it marks worker C as dead, and it sends a message to worker A and B and says, you are now responsible for worker C's records. And so worker A and B grab those events out of backup storage, and within a few seconds, they're able to service those queries. So Rubicon Rubicon the product gives you this really nice query interface. It has these IDE-like features where you get the autocomplete on the different attributes, and you can do type ahead find on your query. It then gives you the ability to visualize that automatically, and you can add those widgets to a dashboard. You can share your dashboards with your colleagues, and it kind of gives you all of these sorts of features. But we've always envisioned that Rubicon isn't just a product, it's something that you can build your own features on top of. So it's a way that you can build an analytics product off of Rubicon yourself. And one thing I don't think Lou mentioned in his keynote is that we released a feature built with Rubicon this week, which is the histogram and percentile feature. So I want to talk a little bit about what that feature is and why we need Rubicon to build it. Okay, so this is the response time graph that everybody who uses the product knows about. And this is a key transaction that we had in our product last week. And on the left side of the chart, you see the average is kind of high, and then it gets a little bit lower. And the average for the entire time period was 400 milliseconds, which isn't very good, but it wasn't bad enough to trigger any alerts. But when we were testing this code in our staging environment, we noticed that it was usually like just really fast, but occasionally it would be really slow. And so we clicked into the percentile chart, which really kind of revealed the problem. The 95th percentile for this key transaction was over 5 seconds, which means that over 5% of the people that were hitting this were getting a really pretty bad response. And we were able to figure out that the problem was due to caching. There was a bug where in certain scenarios the caching wouldn't be filled up. And so we fixed that bug, we deployed, and the 95th percentile dropped down to 500 milliseconds. And so this is a really useful tool to see problems like that, because you can see that the average doesn't really change, the median doesn't change at all, but you see this giant spike in your 95th percentile. Histograms are another product that we released built on top of Rubicon. And these are a great way to visualize the distribution of responses that you have in your app. And if you want to be able to see which transactions are taking up the most amount of time on that long tail, you can just click into one of those buckets and you get a list of the transactions that are taking up the most time there. There's even a pretty cool feature where if you click the Explore button, you can drag the histogram and you can visualize it over time, and it sort of moves over time. And so what you're looking for there is whether the change of the distribution changes as you make changes to your code. But we couldn't build those two features with the data store that we had in place, because to build those features, you need access to the raw events. To do percentiles, to do histograms like that, you need access to the raw events and to be able to aggregate them on the fly. And so since we were collecting the raw events with Rubicon, we were able to query Rubicon to get the data we needed to build those charts. And we couldn't just use the graphs from Rubicon, we needed to just pump that data into New Relic's existing charting system. And so we have a Ruby API, and we're working on clients, or we have a Ruby client, and we're working to make clients in other languages as well. But getting data from Rubicon is actually quite simple. To make the histogram chart that we just looked at, you can just say, Rubicon.NRCL, and then pass in your NRCL query. And so the query to build that histogram is just select histogram duration from page view sent 7 days ago. And that gives you a nice JSON response that you can work with. So you get a result, and you have a count of each bin in the histogram, and you get the bucket size. And you can take that data and you can build your own chart with it using any sort of charting library you want. And it makes it really convenient to do that. Well, how do we build a percentile chart? I mean, again, the query to get that data is just really quite simple. We can just say, select percentile duration, 50, 95, 99, from page view, sent 7 days ago, time series, hour. And that query gives me all the data I need for those percentile charts. And again, we get a JSON response. So the JSON response includes, for each little time period in your chart, it will include a value for the 50th percentile, the 95th percentile, and the 99th percentile, and you can graph that any way you want. And Rubicon allows you to add custom events as well. So if the New Relic agents aren't able to collect all of the different events that you want, you can just add a custom event. And again, the API to do that's really simple. It's just rubicon.insert and then the event name. So in this case, what we are doing is putting in an event for every kind of sale we had on the site. And so you can just name your event. So we named it revenue change. And you can just pass in a hash of arbitrary key values for anything you want. So in this example, we're marking the sales team as the enterprise sales team and putting the amount to 100,000. And that's all you need to do to record an event in Rubicon. And as soon as you insert an event into Rubicon, you're able to query it just like you could any other sort of event type we have. And you query it by putting it in your from statement. So I can just say select count from revenue change, faceting by the sales team. And what that gives me is a pie chart of the number of deals broken up by the different sales teams. So it's really easy to add your own events and to be able to query them quickly. All right, so to recap, we learned a little bit of NERCL, and we talked about what NERCL is good at, aggregating across a lot of events. We talked about some of the features like facet and sense and all the different aggregation functions we have, like histograms and percentiles and averages. We talked about a very brief overview of the Rubicon architecture, how we have a wide cluster, how we're partitioning the data across multiple nodes in the cluster, and how it's all built on really simple Java services. And then we explored the Rubicon APIs a bit, because Rubicon's designed to allow you to be able to do whatever you want with it. So you should be able to access all of the data, get simple JSON responses, and build your own analytics features into your app. All right, so these are the people who've been working on this over the past few months, and we're super, super excited to finally talk to everybody about this, because we've been working on it so hard over the past few months. Starting at 1 o'clock today until 5 o'clock, we are all going to be in the Hacker Lounge, and we'll be doing demos of it. If you want to talk about the architecture or how to build big data systems, come talk to us. We're just like really, really excited to talk about it. And this is launching next year. So if you want to find out more, if you want to be part of the beta, go to newrelic.com/analytics and sign up there, and we'll be in touch. So thanks a lot.